Namaste everyone, welcome back to CodeCraft with Poonam. I am your coding mentor Poonam Agrawal. In our session 3, we mastered JPQL queries, right? That is filtering, searching, sorting data. So all our queries were on a single recipe entity, right? So if you are following my videos, then you would know this. So now, but in the real world, data is never that simple. Okay, so our recipe has a category field. So right now it is just a plain string. That means if we want to list all categories, count recipes per category, or rename a category across all recipes, we have to do it manually. So today in this session, we are going to fix that properly by turning category into a real entity. Okay, that is with a proper relationship between category and recipe. Okay, so this is one of the most important topics in Hibernate. And once you understand it, that is, we have annotations like @1to_many, @manyToOne, etc. Okay, so these annotations in Spring Boot will never confuse you again. Okay. So for your better understanding, imagine your recipe filing cabinet. That is from our previous sessions. Okay. So right now, every card has the word that is main course or breakfast written on it, right? Which is in the plain text. Okay, so there is no physical divider, just text on a card. Okay, so but the problem with this is if you want to rename that is main course to some mains, okay, then you must update every single card. You cannot easily find all cards in one category without reading each one, right? So you can make spelling mistakes. So for this, the proper solution is put a real section divider, that is a category object in the cabinet. Okay, so each recipe card gets a small tab at the top that clips onto the divider. Okay, so now renaming a category, that is changing one divider, all cards update automatically. See how is it? And finding recipes in a category, that is by just looking at behind the divider. Okay, and there will be no spelling mistakes as cards point to the actual divider object. Okay, so that divider is our new category entity. So the tab on the recipe card is the foreign key in the recipe table. Okay. So in this session, what you're going to learn is why relationship between entities are needed. What are the annotations? And what the owning side and inverse side of the relationships are. Okay, and what mappedBy does and why it is required, what @join column does, what cascade type means, okay, why it is powerful, okay. So all these things we are going to see in this session. And also how Hibernate creates the foreign key column automatically, how to query across related entities using JPQL join. And also we are going to see the problem, that is n+1 problem, and how we can resolve it. Okay, so now let's get started. Okay, so the problem with a plain string category is like in our session 3, we had our recipe, right? Where we had a field that is for the category we had string. Okay, that is just a plain text field, right? But the problem with that was there is no guarantee of valid values. So anyone can write anything, right? And renaming a category means updating every recipe row in the database. Okay. So there is no way to store extra info about category. That is like we have description, image, etc. Right? And JPQL also cannot navigate relationships. And also JPQL cannot navigate relationships based on only filter by text value. Right? So the solution is to make category a proper entity. Okay. So here you can see how we are going to enhance category management in our Java application. Okay. So the initial state is plain text, right? That is we have private string category, right? This is plain text. So we have identified the problem, that is no guarantee of valid values. renaming issues, limited info storage, and JPQL limitations. That's why for this, the solution we need to implement is make this private category. Okay, this one, this category as category. Okay, so this is now a real relationship. Okay, so now coming to relational data mapping. So here we have parent perspective and child perspective. So like we have two annotations, that is one to many and at the rate many to one. Okay. So here this parent perspective is just like at the rate one to many annotation. Okay, we have one parent, right? And many childrens. So here you see one parent owns many children, that is at the rate one to many annotation. So here single container for multiple items. Whereas child perspective, we have many child, right? But one parent. So at the rate many to one annotation. Okay. So here many children share one parent, right? And here multiple items linked to one. Okay. So here these two annotations, that is at the rate one to many and many to one, these two annotations describes the same relationship but from different sides. Okay. So now coming to which side of the JPI relationship should I configure? As I told you, we have different sides, right? For that relationship. So that we have here owning side and inverse side. Okay. So here what do you mean by this? So here this is the concept that confuses most beginners. So let's make it crystal clear. Okay. So here owning side is nothing but here at the rate many to one annotation. Okay. So in our example, it is recipe. Got it? So here the side that holds the foreign key column, that is in the database. Okay. So here the recipe table has a category ID column, and your recipe owns the relationship because it stores the actual reference. Okay. And coming to inverse side. So here inverse side is nothing but our at the rate one to many annotation. So here in our example it is category. Okay. So here what it happens is the side that does not hold the foreign key. Okay. So here it uses mapped by to point out to the owning side field. Okay, I will explain you what is this mapped by. Okay, so here mapped by is nothing but it is our category here. Okay, so which means the category field in recipe owns this relationship. So you don't worry, I will show you all this in our example. Okay, so for your understanding purpose, just I am giving you a rough idea. Okay. So you can consider it like we have a recipe card, right? So it has a tab that physically clips onto the divider. Okay. So the tab is the foreign key. The recipe owns the connection. So the divider, which is nothing but our category, okay, just knows which cards are clipped to it. But the actual connection lies on the card. Okay. So here you see owning side, inverse side. So here owning side is nothing but which holds the foreign key column directly, which manages the physical database schema. Okay. And also this uses at the rate join column to define the mapping. So it explicitly creates the reference column. Okay. And coming to inverse side, it does not hold the foreign key. It relies on the owning side for persistence. And it uses mapped by to point to the owner. So it declares the relationship has a logical link. Okay, so I will explain you this in the example so that you will have a better clarity. Okay. So now coming to without mapped by and with mapped by. Okay. So this mapped by is the most important attribute here. Okay. So why? Because it tells Hibernate that I am the inverse side. The other entity owns this relationship. So look at the field named, that is category in recipe for the foreign key. Okay. And what without mapped by? So it means that here Hibernate creates a separate join table. Okay. So which has a category recipe with two foreign keys. Okay. So that is here for at the rate many to many annotation. Okay, so not what we want here, right? So right now we are not discussing about @many-to-many. Here we are discussing only with @one-to-many and @many-to-one here. Okay. So coming to with mapped by here, so with mapped by we are giving our category. Okay. So here Hibernate uses this category ID column in the recipe table. Okay. And here there will be no extra table created. Got it? So here you can see without mapped by, it creates separate join table. Okay. And with mapped by, here it uses existing foreign key. Okay. So now coming to @join column. Here it means that naming the foreign key column. Okay. So here we have the syntax, that is we have a field, right? Category, private category, this is the field name, right? Category. So here we have annotated with @many-to-one and @join column. Here we have mentioned name is equal to category ID. Okay. And then this here we have @join column. Here this name is equal to category ID, this one. It tells Hibernate that add a column named category ID, this one, to the recipe table. Okay, which is in our database, right? So this is the foreign key pointing to. So what happens if you skip this @join column? Then what this Hibernate do is it auto generates a column name. Okay. So here usually category ID anyway. Okay. So but being explicit is better for clarity. Okay. So now coming to Cascade type operations. So in Cascade here we have persist, merge, remove, refresh all. Okay. So here what do you mean by persist? It means that saving parent automatically saves all children. Right. Whereas coming to merge, it means that merging parent automatically merges all children. Okay. Next coming to remove, it means that deleting parent automatically deletes all children. Coming to refresh, refreshing parent automatically refreshes all children. Okay. Coming to all, so all of the above operations are propagated. Okay. So here all this we will use with our cascade. Okay. So here cascade is just like saying when we move this section divider to a new cabinet, move all the cards behind it too. Okay, so the card follows the divider automatically. Got it? So now coming to the n+1 problem and join fetch. So here what it is. So here this is a classic performance trap which beginners fall into. So for that, the solution is join fetch. Okay. So here we see what this n+1 queries are. Okay. So the initial query to fetch recipes. What are the problems? Okay. So initial query to fetch recipes. It loops through each recipe. For each recipe query, its category. So here we have total 1 recipes is plus n categories. Okay. So for this, the solution is to use join fetch. What this will do is we can query using join fetch to load recipes and categories together. And single SQL query fetches all the required data. And join fetch instructs Hibernate to load related entities eagerly. Okay. So here the importance and further learning. That is, it is a crucial optimization in Hibernate. Okay. So we will see this in our next session, that is session 5. Okay. That is lazy versus eager loading. Okay. So now let's see an example. Okay. So here what I'm doing is in this section we have some changes, that is here I'm going to add a category.java file, okay, which is in our entity folder. So here here it is our new parent entity. Okay. So here I will be using our annotation like @one-to-many. Okay. And then I have some made changes in our recipe.java file. Okay. That is here I have updated this string category replaced with our annotation, that is @many-to-one for the category. Okay. And then this Hibernate util.java is unchanged. Okay. And I have made one changes in our main.java file also, that is I have replaced all the relationship demos. Okay, and in Hibernate config file I have updated the category with entity register. Okay, so now let's see one by one. So here this is the new file I have added in category.java in our entity folder, right? So here you can see this is the class, public class category. Here I have annotated with @entity and @table, that is name category. Okay, so here this is our field. Okay, so here we have this generated value and this private string name, private string description, and here you can see this is the one I have added, that is @OneToMany. Here you can see here mappedBy is equal to category, cascade is equal to cascade type all, orphan fetch. So this I have already explained you, right, what is mappedBy. So as I told you that mappedBy is equal to category, which points to the field named category inside the recipe class. Okay, so this tells Hibernate that recipe owns this relationship. So look there for the foreign key. And I also told you that without mappedBy, what happens? Hibernate creates an unnecessary join table, right? And also I have explained you that cascade, right? Cascade is equal to cascade type all. So here every operation on category flows down it. So here every operation on category flows down its recipe. Okay. So as I told you that we have persist, that is our category, which automatically persists all recipes in the list. And I also told you about the remove cascade, right? So that is nothing but our category. So if you use remove, then what will happen? It automatically removes all the recipes in the list. Okay. So you never need to call persist method on individual recipes if they are added to a category. Okay. And coming to this orphan removal is equal to true. So what do you mean by this? So here it means that if you remove a recipe from a category dot get recipes method, okay, so it is deleted from the database. So a recipe without a category is an orphan. So it should not exist. Okay. And then this fetch. Here what it is, fetch type dot lazy. Here recipes are not loaded when you load a category. Okay, they load only when you call category.getRecipes method. So this is performance friendly. Okay, you do not load 1,000 recipes just to display a category name here. Okay, so now coming to this private list of recipes is equals to new array list. Okay, so here what it happens is it always initialize the list to an empty array list. So never leave it as null. Okay, why? Because calling get recipes method on a null list throws null pointer exception. Okay, and then this is our constructor. Okay, no args constructor. This is our args constructor, and we have here add recipe method, remove recipe method, get id getter and setters. Okay, and this is our toString format. Okay, and then coming to our recipe.java file, here also I have updated it. Okay, so here I have updated this recipe.java file to by adding it to @ManyToOne. Okay, so here the key change what I have done is I have removed private string category and replaced it with this our annotation @ManyToOne and @join column. Okay, so here you can see that @entity @table. Okay, here name we have given recipe. This is our table name in our database. This is our class. This is our fields, right? So here you can see this is the change, that is private category. See this one category here @ManyToOne. Okay, this is the one we are joining, this one, right? This is the class, right? Category, this one. So @ManyToOne fetch is equal to fetch type dot lazy, as I have already explained you what is this, right? @join column name is equals to category id, and this is our no R constructor, this is our R constructor, and here we have getter setter methods, and this is our toString format. Okay, so here this @ManyToOne what it does is many recipes can belong to one category, right? So this is the owning side. It holds the foreign key column. And this fetch is equal to FetchType.lazy. What it is doing here is the category is not loaded when recipe is loaded. Okay, it is lazy loading. So it loads only when you call recipes.getCategory method. Okay. So we will explore this in detail in our session 5. Okay. And here this what at the red joint column is doing is here it creates a column called category ID in the recipe table. Okay. So this column stores the ID of the category this recipe belongs to. So this is the foreign key. Okay. And then coming to this hibernate.config.xml, here I have updated, okay, here. So in this file, I have registered both our entities, okay. So here you can see that this one, mapping class, okay, this is our entity, right, category entity and recipe entity. So here these two I have registered in this file, okay. So here registering this both entities, order matters here. Why? Because first parent will come right before child. So that's why here first I have this registered this category. Okay. And then here recipe. Okay. So registering category before recipe is actually a good practice. Why? Because Hibernate creates the category table first. Okay. And then the recipe table. Okay. So with the foreign key reference. That's why. So that's why this order matters. Okay. So now coming to our main.java file. Okay. So here, this is our main class, main method. Okay. So here we have first demo that is to save category with recipes. Here we are using Cascade. Okay. So here you see that this is our category objects, right? So here we have main course, breakfast, snacks. Okay. Okay, so here you can see we have in main course we have new category. Okay, that is main course. Here we added this description and for the breakfast also and for the snacks also. Okay, and then here we are adding recipes in our main course. Okay, here you can see with all corresponding fields. Okay, and then for the similar with breakfast and snacks, and then here we are creating a session that is session 1. Okay, we are opening the session and then we are beginning the transaction. And then here we are only persisting the category objects here. You can see that we are not persisting this individually. All these recipes, right? Here you can see that we are using the categories, right? And then we are committing and then closing this session, okay? After that, this is what the print statements we are giving, okay? And then coming to this one next demo, that is load category. That is nothing but we are accessing recipes using this @OneToMany. Okay, so here we are opening another session. Okay, and here we are loading the main course category. Okay, by its ID here you can see main course dot get ID. Okay, and then here we are accessing this list. Okay, that is we are getting name for the loaded categories. Okay, so this will trigger a second SQL query. That is here what we are doing, we are lazy loading. Okay. So here you can see it will loop one by one all the recipe names, its cook time in minutes. Okay. And then we are closing this session. And then coming to our next demo, that is load recipe. That is we are accessing category here using this @ManyToOne annotation. Okay. So here you can see that here we have this. Okay, palak paneer recipe ID. Okay, here we are finding by ID here. You can see main course dot get recipes dot get here. This is the index position. Okay, dot get ID. And then we are opening this session and then we are loading the recipe. Okay. And then here we are navigating it to the parent category. Okay. So here this will trigger to select statements. Okay. So here also we are performing lazy loading. Okay. And then we are closing this session. Okay, and then this is our next demo, that is JPQL join. So here we are querying across all the entities. Okay, So here for that we are opening another session, and then here we have list of recipes. Okay, so here you can see we have used dot create query. Here we have select statement. Okay, so here we have used join, where clause, order by clause. Okay, and then here we are setting the parameter. Okay, which parameter? That is category name. Here we are giving breakfast. Based on that we will get the result. Okay, for that here we have used this get result list method. Okay, so here what this join query will do, it will fetch all the recipes that belong to the breakfast category. Okay, and this will, and then here we are looping one by one. We will get the name and cook time in minutes. Okay, and then here we have list of recipes. Here we have all categories. Okay, so here it will fetch the category data alongside recipe in one query using join fetch. Okay, here you see. Here with select statement we have used this join fetch. Okay, that is category C ordered by name. Okay, so this will avoid the n+1 problem. Okay, as I told you, the solution for n+ problem is to use this join fetch. Okay, so what this will do, so it will load everything in a single SQL. Here you can see. Okay, and it will loop one by one, and here you will get the category name. Okay, and then we are closing this session, and this is our fifth demo where we are adding a new recipe to an existing recipe. For that we are just opening this session and beginning our transaction. So here let's load our snack category. Okay, so for that here you see that session 5.find. This is our category dot class, and here we are getting the ID for the snacks. Okay, and then here we are creating new recipe, that is masala papad. Okay, so here we are giving the recipe name, it's cookie time, and is it vegetarian or not, and then we are adding it in our snacks category. Okay, so here you see that we have not added any explicit persist method here. Okay, so here what it happens is this cascade type dot will dot all will handle it. Okay, and then we are committing the transaction and then closing it, and then we are verifying whether it is saved or not. Okay, so for that we are again opening the session and then verifying whether that recipe got saved or not by finding it. Okay, so here verify session 5.find category.class snacks.get id. Based on id we are finding. Okay, and then here it will loop one by one, you will get the name. And then this is our sixth demo. Here we are using delete category. Okay, so here we are using cascade. So delete, that is cascade deletes all its recipes. So here before deleting we are checking the count. Okay, so for that we are opening the session and we are checking the count. Okay, and then closing this. Okay, and then after that we are deleting. Okay, deleting by again opening the session and beginning the transaction. So here we are deleting. Okay, so after that it will remove. We are using this session 6.remove to delete. Okay, and then it will commit, and then we have to close this session. So here we have this remove, right? What it happens here is as we have used cascade type dot all, right, in our this category dot java. Here you see this one, right? This one. That's why it will so it will remove. Okay, so it delete. So here what will happen is delete runs for all the recipes in this category too. Okay, and then verifying recipes were also deleted. Now we are verifying the recipe which is deleted. Okay, so here you can see for that we have created a query. Select count. We are okay, we are counting how many recipes are there after delete. So from recipe, okay, and we will get the count after deleting the snacks. Okay, and then this is our final state, that is remaining categories and recipes. So here again for that we are opening the session, and here we have list of categories. Okay, here we have created a query, that is select C from category order by name, and here we are using get result list method. Okay, in our last session, that is session 3, I have already explained you about this method, right? And then here we are looping one by one. Okay, so here we will get name, cook time in minutes. Okay, and then we are closing this session, and then Hibernate util dot shut down. Okay, so now we will run this. So here you see it got started. Okay, so here this is our first demo to save the categories, right? So here you see that we have persisted only categories, that is main course, breakfast, snacks. Here individually we are not saving each recipes for the particular categories, right? So here you see that Hibernate generated the here statements. Okay, before that here you see that Hibernate first created a category table and then recipe table. That's why order matters. Okay, in the configuration file I have shown you, right? Mapping. First we have used category, right? And then we are mapping this recipe. Okay, so here you see Hibernate generated the insert statements, okay, for all the recipes which is present in main course, breakfast and snacks. Okay, here it is. And then it saved 3 categories, this one. Okay, and then here you will get this category IDs, that is main course 1 is equal to 1, breakfast is equal to 2, snack is equal to 3. So here you can see that here total we have 11 recipes, right? So here we have used Cascade, right, in our this category.java file, right? So we only because of that cascade, we only called persist method 3 times. So here individually you need not have to save all the recipes. Okay, because of this cascade type dot all. Okay. So next, coming to our this another demo, that is load categories. So here we are finding based on the ID here, get ID you see. So for that here Hibernate generated this select statement. Here you see that category ID is equal to 1. So we have not given any ID, right? That is equal to 1. But here you see that we got that one. So why? Because it automatically generated ID. Okay. So name is main course and description is this one. So here you see that. So here recipes in main course. Okay. So Hibernate generated the select statement. Okay. That is from recipe table. Okay. So here we have all these recipes in our recipe table. Okay. And then this is our demo 3 load recipes. So here we are using this @ManyToOne annotation. Okay, so here you see this Hibernate generated the select statement that is from recipe table. Okay, and here it loaded this recipe that is palak paneer. Okay, and get ID. So here you see this recipe belongs to the category main course. So here it loaded this recipe from the recipe table, and then Hibernate generated the select statements from this category table. Okay, and then here it displayed here this category description. Okay, this one. And then this is our demo for JPQL join. Okay, here you see Hibernate generated this select statement from the recipe table. Okay, and it joined the category table as well. Okay, so here you see that we got this breakfast recipe via join. Okay, here for in the query we used join, right? This one. So here you got this. And when you use this join fetch, here you see that this is the single SQL query which you have to provide. Okay. So here you see that this is what Hibernate generated. That is from recipe table, it joined the category table. And here you got all this recipes from all the categories. Okay, when you used only join, here what you have mentioned, only that thing got displayed here, right? When you use this join fetch, you will get all the recipes from all the with all the categories. Okay, so for the 11 recipes you need to write only one query for the join fetch, whereas if you go with the join, then you need to have to write manually or for all the recipes. Okay. So now this is our demo 5 here. Okay, that is to add a new recipe. So first we are checking the count, that is before adding recipe here, that is 3 we have. And then to add the recipe here, generated Hibernate generated insert into statements, and then here you see Hibernate generated the select statement to get the snacks. Okay, so after adding here you see that 4 recipes. Okay, and then this is our sixth demo here for the delete category. Okay, so here you see we are counting before deleting. So for that, here Hibernate generated this select statement, okay, for the count. So we got 12 recipes, and then after that you see that it generated query from the category table and then recipe table, and then it deleted 4, and then after deleting here we have 4 recipes inside. Okay, deleting categories, we have snacks, that is 4 recipes inside. And after that here you see that this one delete statement got generated here by the Hibernate. Okay, and then you see here we have the count total 8 after deleting. So here you need not to delete one. So here you are not deleting each recipes, right? Here just you use Cascade. We have used Cascade type dot all, right? Because of that all the recipes in this week it got deleted automatically. Okay, so here it deleted 4 recipes via Cascade. Okay, and then this is our final state. Okay, this one, remaining categories and recipes. So here you see Hibernate generated the select statement from the category table, and then this is from the recipe table, and here it is with all the remaining recipes you have in each category. That is in breakfast you have this, and for the main course also it generated a select statement from the recipe. Okay, this one recipe table. So here you got this main course. Okay, and then here the session factory closed cleanly. Okay. So in Spring Boot, when you write this annotation, that is at the rate one-to-many, okay, and all this what I explained you, that is mapped by Cascade. Okay, so now you know exactly what each attribute does and why it is there, right? So, and when your Spring Boot app has a performance issue because loading recipes is slow, you now know to look for the n+1 problem. You can fix it with join fetch in your @query annotation. Okay, so this is for today's session. If you like my video, then let me know through comment and hit the like button and share it with your circle so that it will be helpful to them. And do not forget to subscribe and hit the bell icon so that you will not miss any of my videos. Till then, keep learning, keep growing. This is Poonam Agrawal from CodeCraft with Poonam signing off.